Hi, so this is the second video for college algebra for the section exponential functions. So last time we looked at what an exponential function is. It's a function that has a base that is positive, so not zero, or I'm sorry, bigger than zero, there we go, positive, and also not 1. And then our exponent happens in, our variable happens in the exponent for exponential functions. So we looked at what those graphs look like, how we make the table, and all the characteristics of the graph. So what we'll look at in this video is a specific base that you might see. And it's a new number that maybe you've never heard of before. And it's a number called e. Now, e is something that it's a number that's in the same family as pi. It's called an irrational number. So it never ends and it never repeats. So the best we can do is an approximation of e. So we use little squiggly lines like that for approximation. And e is approximately 2.71828. And then we have to put a dot, 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 because it goes on forever, just like pi. So we are going to use our calculator a lot for e, because not too many people, probably no one, knows powers of e off the top of their head, except for a few here and there. So let's look at how we would do this in the calculator. So I'm using a TI-83, but you should be able to find e somewhere on your calculator. If you're using a scientific calculator, e should be there somewhere. So on my calculator, again, this is a TI-83, I can find e in 2 separate places. I either find it over here, it's a little yellow lowercase e above the division symbol, or I find it here, an e to the x in yellow above the ln key. Now these are the same e. Just a warning though, these little capital E's are not the same. So you want to look for lowercase e, and that's the value that we're talking about in this section. So if you use, I have to use the yellow second key, go to e. So if you enter in just e, it'll give you that number we just wrote down a second ago. Okay, so if you have a calculator that doesn't have this button, so what this button does, the ln, it's the same e, it just sets you up to raise e to an exponent. You don't ever have to use it if you don't want to, because this thing right here also raises e to an exponent. So either way you want to, or either key, you want to use either the e with the exponent on it or just the e, totally fine. So let's practice finding some powers of e. Our first example in the notes is e squared. So I can go to this e that sets me up with an exponent and use the 2, close the parentheses, hit enter, and e squared is about 2.39-ish. And those numbers go on forever. All right, so make sure you're able to get that. Depending on what kind of calculator you have, sometimes you do e and then the exponent, sometimes you do the exponent and then e. So just try a different order until you get the number we're looking for, that 7.39. So the next one we're going to look at in the notes is e to the 0. Now this is the 1 power of e we should know, because any number to the 0 power is always 1, and while e is a special number, it has all the same properties as all the other numbers we know about. So e to the 1 should be 0. Sorry, e to the 0 should be 1. And sure enough, if we do e to the 0 power, we get 1. Just like we should. Okay, so if you're putting it in your calculator and you're getting 1, that means you're doing it correctly. If you're putting it into the calculator and you're getting something other than 1, you might need to do the exponent first, then do e, depending on how your calculator likes it. Next, we have a negative exponent. Now, we haven't really used the calculator much with negative and positive, at least we haven't in class, just because we can usually do those in our heads pretty quickly. But if you have to put in a negative exponent on e, you need to know which button to use, because we have 2 buttons that look almost the same. We have a negative button and we have a subtract button. They look the same, they are different. Your calculator will tell you if you use the wrong one. So if we want to do e to the negative 0.5, we do e, takes us to an exponent, negative 0.5. So we have to use this negative down here. Hit enter and we get 0.607-ish. Goes on forever. If you use the subtract button instead of the negative button, this is what you will see. So we'll do subtract 0.5. Your calculator freaks out because you made an error. It doesn't notice that unless you're subtracting things. So it didn't see any numbers being subtracted there, so it found an error. So if you're getting an error, make sure you're using the negative button and not the subtraction button. Those are different things. So now let's look at what the graph of e to the x looks like, or what an exponential function looks like when its base is e. I am not going to make you graph these in this format because it's very difficult to ask you to graph something through Canvas. But in all honesty, if we were doing this in class, I wouldn't make you graph a function with a base of e by hand because we can't get it right. We are estimating every step of the way except for that one point where we put 0 in for the exponent, or where the exponent becomes 0. Other than that, we're just estimating what these things are. We have to chop off the digits somewhere. You can't really graph it accurately anyway by hand, but you should be able to make a table. Now let's talk about e to the x. E is some number between 2 and 3, closer to 3 than it is to 2. So we already know some things about this graph. We know that it's going to have, we haven't done any transformation, so it's going to have a horizontal asymptote that is the x-axis. We know it's going to be increasing. We know it's going to have a y-intercept of 0, 1. We know its domain is going to be all real numbers. We know the range is going to be 0 to infinity. So this takes on all the same characteristics as the graphs we looked at in the last video because e is just a number between 2 and 3. So the graph doesn't have any special properties just because the base is e. So let's make a table just to make sure, this is really to make sure we know how to use our calculator. So if we were graphing this like we did in the last video, I like to choose the x value that is 1 less than wherever the y-intercept ends up. In this case, the y-intercept just stayed where it was. We didn't have a transformation. So I would do -1, 0, 1, 2, and 3. So we have 5 values, and if we wanted to graph this thing, it wouldn't get totally out of control. All right, so let's use our calculator to figure out these values. We already know e to the 0 is 1. We already know e to the 1 is 2.718. Goodness, still a lot of decimal places, right? E squared, we already found out, was about 7.39. So the last thing we need to figure out is e cubed, and in my calculator, I get 20.08 is what my calculator shows. I don't know why it's not showing up there, but it's about 20.09. Okay, and then we also want e to the -1, being very careful that we are using the negative button and not the subtraction button. Almost. There we go. Okay, so hitting enter, when we do e to the -1, we get about 0.368. Okay, now I want you to imagine trying to plot any of these numbers accurately. Not gonna happen. This one we can do very easily, but these 4, it's not gonna work out. So I am very interested that you know how to make this table, and we're gonna use these to try to illustrate what this looks like in comparison to the 2 bases or the 2 whole number bases that are around it. So for -1, we have 0.368, kind of. Okay, for 0 we have 1, 1 we have 2.71828, here-ish. For 2, we have 7.39, about here. Okay, and that's kind of where we're going to stop because I don't have enough room to go up to 20.09. So let's connect these dots, remembering what these are supposed to look like. We're supposed to get very close to this line but never touch it. Now, let's look at the 2 whole number bases around e. So e is 2.71828, etc., meaning the 2 whole number bases around it are 2 and 3. So let's look at what 2 to the x looks like. We already graphed this. So 2 to the x is going to have the point -1, 1/2. It's a little bit higher than this one. 0, 1, same. 1, 2, 2, 8. Okay, so we can see, yeah, 2, 8. Sorry, no, what am I doing? 2, 4, goodness. I'm wondering why it's not looking like it's supposed to look. Well, it's because I was doing the exponent wrong. All right, so if we look at what we've got here, 1, 2, yeah. There we go. So if we look at what we've got here, we can see that these two curves match at 0, 1, but this one grows a little bit faster because the base is bigger. Let's look at what happens whenever we look at 3, a base of 3. So we're going to look at 3 to the x and what that would look like. Okay, so we know 3 to the -1 is 1/3, so it's going to be a little bit lower than this one. 3 to the 0 is 0, so we're kind of all meeting there. 3 to the 1 is 3, and look at what I did. 2's right there, y'all. When the graph doesn't look like it's supposed to, that usually means you did it wrong. Okay, 1, 3 is here, and 2, 9 would be way up here. And so if we draw the graph, we can see that it starts at the bottom. They all meet at 0, 1, but it curves up much faster. So this is our e to the x, that number between 2 and 3, a little closer to 3 than it is to 2. Here's our 2 to the x that doesn't grow as fast, and our 3 to the x that grows faster. But notice where the e to the x is. It is between these two curves and a little bit closer to the 3 to the x than it is to the 2 to the x. So again, it's got the same shape, got the same properties, it's just got that base e. All right. So what we'll do in the next video, I think we'll stop here. What we'll do in the next video is look at an application to exponential functions. We are currently living in an application of exponential functions, but there is another one whenever times are a lot better and more normal that we'll talk about in the next video.